Hi, welcome back to our Honors Geometry playlist. On this video, we're going to look at how to start writing some geometric proofs. So the first thing you need to always know about writing a proof is that you will be given some facts, some baseline to start with, and you'll be asked to use theorems, postulates, or axioms to justify how you can solve and prove a specific result. So in this case, I'm being asked to prove that x equals 8 given that AED and CEB are vertical angles and AEB and CED are vertical angles. So usually the first thing I would do is I would ignore the proof and I would ask myself, what would I do to solve this problem if I didn't need to write it down? If I didn't need to show any work, what would my first step be? Well, I would take these two parts and I would set them equal to each other. So what are those two angles? Those are angles AED and BEC or CEB. So I should always ask myself, if I'm looking at a diagram, what relationship do I see? And I'm going to write that out in letters. So in this case, I've already given that to you, that AED and CEB are vertical angles. And I know that since they are vertical, these two expressions should be equal. Well, I can't do the expressions yet, but I can talk about these angles. So I could say that these two angles, angle AED, or the measure of angle AED, would be equal to the measure of angle CEB. And I know that because vertical angles are always equal, they're always congruent. And that would be my vertical angles theorem. So first thing I'll always start with is the given, and then I'll do the equation, whatever relationship I see, in letters. Those should be my first two steps in any proof. The third step, once I've got the equation written out in letters, well, I know what angle AED is. I know that angle is 7x minus 2. And I know that angle CEB is 11x minus 34. So the first few steps of your geometric proofs should look pretty similar. Now you might write down more given statements than this problem has. So maybe you write down 3 or 4 given statements instead of just one. If you want to break up your givens into more than one step, you can always do that. Or if you want to list several things in your first box, in your first proof step, I would accept that as well. And from here, it's just an algebraic proof. So from here, you're just using your addition, subtraction, multiplication, and division properties of equality. So I would use my subtraction property of equality, and then my addition property of equality, and this problem becomes a little bit more interesting because I'm going to need an extra space here. I've got 8 equals x by the division property of equality. But I wasn't asked to solve and prove that 8 equals x. I was asked to prove that x equals 8. So I need to know some of my postulates or theorems. Specifically, I need to know what theorem allows me to switch the order of my equation once I have it solved here. So that switch, that's allowed by the symmetric property. Students often get this confused with the reflexive property, but I usually think symmetric switches it, reflexive does not. So symmetric to switch, and I get x equals 8, which is exactly what I wanted. All right, let's try zooming out here. Let's try one more. I want to prove that y equals 7. So if I want to prove that y equals 7, well, what angles have, and this should be labeled as 126, what angles have y in them? Well, AEB, angle AEB, angle AEB is one of them, and what's the second one that's also related to that angle? Well, it should be angle DEC. So I should be able to say that angle AEB and angle DEC or CED are vertical angles. And I got that from the given statement up above. And now I know they're vertical angles. I know that vertical angles have a very specific relationship. I know that if they're vertical, then they should be equal. And I know that by the vertical angles theorem. Okay, so first step is always given. Second step, what relationship do I see in letters? And the third step would be what equation can I write? What numbers can I use to write an equation here? And in this case, I see 18y and 126. So AEB is 18y and DEC is 126. So I can substitute in those values. And from here, it's just an algebraic proof. There's only one more step where you'd get y equals 7 by the division property of equality. But once you get to any geometric proof, the step where it becomes an algebraic proof, most students are okay with finishing the proof from there. It's that first part there that will often get students a little bit stuck. All right, let's try another one here. First thing I should always do in any proof, I should write the given statements. Once I've got the given statements, I should look for what relationship I could use to solve for, in this case, x. So ignoring the proof, how in the world would you solve this problem for x? Well, I want to set up an equation. I want to say that, 2 times x plus 5 plus another 3x should equal 20. So I really want to say that, but just like we did in chapter 1, you should write that out in letters first. I want to say that I see that relationship in letters. But what theorem or postulate tells me that I can add 2 segments to get a bigger segment? Well, as a little hint here, it is the segment addition postulate. So I always start with the givens, and then I'll look for some relationship, some theorem or postulate that tells me what equation I could set up in letters or what relationship I have in letters. And then finally, the step that gets me to an algebraic proof is where I begin to substitute numbers for those letters. And I found that most often the trouble that students have with geometric proofs is in these first 2 to 5 steps. Really, once we get to algebra, it's not that bad. But setting it up from the givens to your postulate or your theorem or your relationship between the different objects to substituting, that's the part that really gets us stuck. Why don't we try one more? I'm going to try to challenge you here. Let's say angle 1 and angle 2 are complementary. The measure of angle 1 is 3x, and the measure of angle 2 is 6x. I want to prove that x equals 10. So I would ask you to pause the video and try to get the first 3 or 4 steps down here, and then unpause and check your work. So first thing I should do is I should write down my given statements. And if you want to do this in 1 step, you can. If you want to bring this over in 2 steps, you can do that as well. I'm going to do 2 steps just so that I can write a little bit bigger. So I got given, given. Now step 3 is where often we struggle. I need to look back at my given statements, my diagram if I had a diagram, and I need to ask myself what vocabulary words or what postulates or relationships or theorems do I see in my diagram or in my given statements. Well, if I know 1 and 2 are complementary, well, what do I know about complementary? I know that if they're complementary, if angle 1 and angle 2 are complementary, then I know that I could add those up to get 90 degrees. And I know that because complementary angles always add to 90. So by the definition of complementary angles, I know that those angles should add to 90. And step 4 would be, well, I know what the measure of angle 1 is, and I know what the measure of angle 2 is. So I could say 3x plus 6x equals 90 by substitution. All right, now if you needed help getting here, that's okay. I would ask you to pause the video one more time and see if you can write the rest of the proof from here. Now, once I get to this step, it's all algebraic, and I need to ask myself, how would I solve this, and how could I explain my work to a reader or a classmate or a teacher? Well, the first thing that I would do is I would combine my like terms. So 3x and 6x becomes 9x, and I combined my like terms to get there. And finally, x would be 10 by the division property of equality. And the key takeaways that you need to get from this lesson are: the first step is always given, or the first few steps, depending on how you break that up. the next step, whatever that equation is, needs to be written out in letters, right? You need to write that either as the name of an angle or the name of a segment, or in this case, using the measure of angle 1 and the measure of angle 2. Instead of just going straight to the numbers, we're using the names of those objects. Same thing here. In my segment addition postulate, I used the names of those segments. I didn't put the numbers in yet. Or in my first few problems, I used the names of the angles. I didn't go straight to the numbers, straight to the equation. Once I've got that relationship written in, that theorem, that postulate that tells me how I know those two objects are related, then I can start substituting. And my last step that will make it change from a geometric proof to the rest of it being algebraic is that substitution step. After that, it's all algebraic. And so far, it looks like you guys have done a great job with algebraic. So keep up the good work and let me know what questions you have.